You are welcome to Maths Clinic series. In this video, we are continuing the series of trigonometry, and this is video number 6 of the series. And today we want to look at special angles. Special angles. By the end of this video, you should be able to deduce the values of special angles in trigonometry, express the value of obtuse and reflex angles in acute angles. Now, the special angles we are going to deal with are the following: 30 degrees, 45, 60, and 90. What we are going to do basically is going to find the value of maybe sine 30. What is sine 30 without using calculator? What is cos 30 without using calculator? And what is tan 60 without using calculator? So this is what we are going to do basically in this aspect of the course. Now, I want you to draw an equilateral triangle, or maybe let's look at what I have here. This is an equilateral triangle. First of all, you have to know what an equilateral triangle is. You can pause the video and think about everything you can know about equilateral triangle. Write down their properties, or 8 properties. I'm sure you realize that an equilateral triangle has all sides equal, and all angles are also equal. And because angles are equal and all sides are equal, the interior angles will be 60 degrees to each of them, so that it will sum up to give you 180. Now, what we are going to do is, since the sides are equal, we want to assume the size to be 2 centimeters. You can also assume to make it 5 centimeters. You can assume it to be 10 centimeters. I mean, you get the same answer as we are working on. But to make my work very easy, I've assumed it to be 2 centimeters each. And for that matter, the interior angles are also 60 degrees because that one is fixed. Okay, now the next we are going to do is to divide this triangle into 2 equal parts. Remember that an equilateral triangle has 3 lines of symmetry. So this is a line of symmetry which will divide this into 2 equal parts, such a way that folding this side onto this will fit exactly. And so we have this. Now, since this is a line of symmetry, it meets the baseline here at an angle of 90 degrees. So we can have an angle of 90 degrees for that. So this is 90 degrees. Now, since this is 90 degrees, it helps us to know that one side of the triangle here becomes right angle triangle, and the other side also becomes right angle triangle. And for that matter, the angle here becomes 30 degrees, right? The same thing applies to this one, also becomes 30 degrees. Now, let's assume that we don't know the side here, so we want to give it a name. Let's call it x. But we know that the side here is going to be 1, the side here is going to be 1 because the whole AB is 2 centimeters. So once we divide it into 2, the side here becomes 1, the side here also becomes 1. Now I can redraw the whole diagram to look like this. 90 degrees is here, here is x, here is 30 degrees, 2 centimeters, 1 centimeter, 1 centimeter, and then the 60, 60. Now we can take any side and calculate for the value of x. And here we can apply Pythagoras theorem, which says that s squared, that is this s squared plus 1 squared is equals to 2 squared. I can go by this same side, which will be the same thing. So making s the subject, we can find s to be root of 3. So I can put root of 3 here in place of x. All right. So that is that. Right. Now, if you ask me to find cos of 60 degrees, we know that cos 60, if you say 60, cos says ka adjacent, so 60 is here, its adjacent is 1, and its hypotenuse is 2. So cos 60 should give us 1 over 2, and that is 1 over 2. If you put calculator on cos 60, you always get 0.5 or half. So if I put 5 here, 2.5 here, I'll get the same value. If I put 10 here, 10 here, 5 here, 5 here, I'll get the same value. You can pause the video and try it and see. In that case, the value here also will change, so bear in mind. And it will still come to the same value here. If I say sine 60, that also, you know, sine is so opposite over hypotenuse. Opposite of 60 is root 3. Its hypotenuse is 2. And for that matter, we get root 3 over 2. If I do the same thing for tan 60 also says twa, opposite over adjacent, opposite over adjacent, and so that will give us root 3. That is root 3 over 1, and the same as root 3. Alright, now let's do the same thing for 30 degrees and see. If I pick cos 30, and I can take any of these 30 to give me the same answer. So if I say 30 here, cos is ka, adjacent over hypotenuse. So adjacent of 30 here is root 3. Hypotenuse is this. So that will give me root 3 over 2. Then sine 30 also says so. Opposite of 30 is this. Hypotenuse is that. So 1 over 2. Then tan will give me the same as root 3. That's tan of 30 is 12. Opposite over adjacent. So ideally, tan is supposed to give us opposite 1 over, let me put my pen here, 1 over root of 3. So 1 over root of 3 is the same as root 3 over 3 because we can rationalize this. When you rationalize and you divide both sides by root of 3, then you multiply 1 times root 3 will give us root 3, and root 3 times root 3 is root 9, and root 9 is 3, so we get back this. We always prefer leaving our answer at the denominator side being irrational, and so with calculator it will give you root 3 over 3, it won't give you 1 over root 3. So anytime you get 1 over root 3 as your answer, you have to rationalize the denominator so you can get your answer as such. Now, a reflective question, something I want you to think about. What will happen if you choose 10 centimeters for the size of the quadrilateral, of the equilateral triangle, like I said earlier on? What will happen? You get the same answer. You get the same answer. All right, good. Now, we want to look at it in terms of 45 degrees. What will happen in terms of 45 degrees? What we've done right now is 60 degrees, 30 degrees. What about 45? With 45, we'll start with right angle triangle. And this right angle triangle, we want to look at it in terms of isosceles right angled triangle. In that, the two sides here, we're going to consider them to be equal. And when they are equal, then this triangle becomes an isosceles triangle. But because of the 90 degrees also over here, it makes it right angle triangle. So we can call this isosceles right angled triangle. So since we are saying so, let's assume that here is 1, here is 1. You can also make it 2, 2, 3, 3, 4, 4. But I want to make it 1, 1. And find the hypotenuse to be, let's call it x. Now, because here is 1, and here is 90 degrees, these two angles automatically must be 45, 45. Because once these two sides are equal, these two angles also ought to be equal. And that makes it an isosceles triangle. And since they are equal, then we can make it 45, 45. And that's the reason why we chose it to make it isosceles triangle. So the x here can be calculated using Pythagoras theorem. And when you go through that, you get s to be equal to root 2. So I can put root 2 in place over here. And if you ask me what is cos 45, cos 45, I can say ka means adjacent over hypotenuse. Adjacent of the 45 here is 1. And its hypotenuse is root 2. And if I use this 45 to its adjacent is still 1, and its hypotenuse becomes root 2. So I can say 1 over root 2, which is the same as root 2 over 2 if I rationalize the denominator. If I take sine 45, it will give me the same value. Observe that the answer here is the same as the answer here. Well, we'll explain that further. Then tan 45 is going to be, if I take this angle as my 45, opposite over adjacent, 1 over 1. If I take this one to opposite over adjacent, 1 over 1, and 1 over 1 is 1. All right. The observation I want you to look at. You see, when you solve cos 45, we saw the answer to be root 2 over 2. Sin 45 is the same thing, right? Cos 60 half, sin 30 also half. Why is this so? The big question is, why is this so? Why is it that cos 45 sin 45 is this, and then cos 30, cos 60 and sin 30 is half? Again, too, if I also look at it in terms of cos 30, it will be the same as sin 60. You can go and verify that from the previous ones we've done, and that is true. Why is this true? Let's see quickly. Now we can use the GeoGebra to verify this. Now this is right angle triangle, and this is the angle here, 33.69, 56 point that, and these two angles must add up to 90 degrees. And because they must add up to 90 degrees, sine of one of them is 0.55 and cos of the other is 0.55. If I change this value to this, cos 45 sin 45 will give us the same value. If I change it to, let's say, this, 28.61 and 61.63, when you add these two values, you get 90 because here's 90. And you can see that the sine of 28.61 is the same as the cos of 61 point that. Because they are complementary, we said that sine and cosine, the sines, we have sine of an angle, and complement of the sine of an angle is what we call cosine. And for that matter, the two, if they add up to 90 degrees, then their value ought to be the same. And this is very, very true for all right angle triangle, that the two angles that comes as the acute angles, if you take the sine of one, the cos of the other, and because the two of them add up to 90, will always give you the same value. So that is the proof of the fact that anytime you have sine of an angle and cos of an angle and the two angles add up to 90, their value will always remain the same. This will never be true if the triangle is not a right angle triangle. And you can see here that 45.69 and 60.26 is not the same value. It will only be true if the angle we are dealing with is right angled triangle. Alright, with this we come to the end of video number 6. So video number 6 has ended here. Thanks so much for watching.